4.5, the real zeros of a polynomial function. So in 4.4, we had our first look at solving polynomials and rationals that were inequalities. So here we are going to be looking at only polynomials, and they will be equations, not inequalities, so you don't have to do all that testing with the number line. But we will be learning some new theorems today that will help us in the process of solving. So in this first video, you're just going to look at examples 1 through 3. And these are very important examples because these will build up. And by the time we get into the second video, we will be taking what we are doing in examples 1, 2, and 3, and then putting all of that together to actually solve. So this first video is, let's look at the steps individually, and then the second video is going to be, now let's put this all together. So please make sure that you do have this classwork done before you move on to the second day of 4.5. So in example 1, use the remainder theorem to find the remainder when f of x is divided by x minus c. X minus c, let me change my color so I'm not using red. Let's use pale blue. So x minus c is the factor that you are given. So we're going to divide by that, but I'm finally going to show you guys synthetic division, not long division. You are welcome to use long division though. So the remainder theorem just states that I can divide this polynomial by x minus 2 and get a remainder. And then it says use the factor theorem to determine whether x minus c is a factor. So the factor theorem is if when I divide I get 0, then it is a factor. So we will be using that to help us solve. So let's go ahead and refresh our memories on synthetic division. Synthetic division uses one of your x-intercepts, the solutions, the root, the 0, whatever it is that you find. So if I take x minus 2 and I set that equal to 0, my x is 2. So to use synthetic division, I put positive 2 in my backwards house. Now to set up the synthetic division, you will use each of your coefficients. And remember, if something's missing, you must use a placeholder. So this is 3, 2, 1, none, so nothing is missing. So I put 4, negative 3, negative 8, positive 4. Leave some room to write. And then the last value that I get is my remainder. So I start by dropping the 4. So synthetic division is weird because we're dividing without actually doing any division. This is all multiplication. So I drop my first term. Then I multiply. So you guys are going to want to probably watch this a couple of times. I multiply 4 times 2, and that gives me 8. Now I add. Negative 3 plus 8 is 5. Then I multiply again. 5 times 2 is 10. Then I add again. When I add, I get positive 2. Now I multiply again. And I get 4, and my remainder is 8. So I have a remainder of 8. And that's just the remainder theorem. I can divide by a factor, get a remainder. The factor theorem, if when you divide you get 0, then that factor is an actual solution. Since I did not get 0, this is not a factor. X minus 2 is not a factor because I did not get 0. We got 8. So I'm going to go on to the next one. If you need to watch that again, watch it again, watch it again, watch it again. You're going to see me do that a couple of times in this video. So for this next one, I put this equal to 0, so x will equal negative 1/3. So negative 1/3 is the value that will go in my backwards house. Now let's see. I have a 3, a 1, -3, and a 1. So let's look for placeholders. I have 4, 3. My exponent of 2 is missing, so that will need to be a placeholder. So I have 3, 1, 0, -3, and 1. If you forget a placeholder, you will end up getting this wrong. Please be careful. You must have your placeholders. So this is the 4, this is the 3, 1, and then no X. The 2 is missing. So I start by bringing down my first value, which is 3. Then I multiply. So -1/3 times 3, that's easy. Your 3's cancel, leaving you with -1. When you add 1 and -1, you get 0. Well, 0 times -1/3 is 0. When you add, you get 0 again. Multiply by 0, you get 0. So now I add, and I'm going to get -3. So your answers to your multiplication will always go in this empty space. Please make sure that you leave space. And then you add, then your whatever value you get, you multiply. Put your answer in the empty space, add, multiply. So I have -1/3 times -3. 3's cancel. And what is -1 times -1? You get +1. And then I end with 2. So my remainder was 2. So this is not a factor. So remember, what must it equal for that to be a factor? It must equal 0 for the remainder must equal 0 for what you are dividing by to be a factor. And that's going to help us a lot when we are solving. So I can go through the synthetic division and I will know I have one of my solutions once I get my remainder to be 0. It is very, very easy to make a mistake here. And you need to be very, very careful when you are going through this. You don't want to get a 0 when you were not supposed to, and you don't want to miss a 0 when it was supposed to be a 0. Because that's going to make a lot more work for you and just add up to a lot of frustration. So please be careful with your signs and the work that you are doing, please. So let's look at example 2 now. So example 2, tell the max number of real zeros. That's going to be coming from the fundamental theorem of algebra that you guys did go over in Math 3. And then we're going to determine how many positive and negative zeros there might be. So we're just determining right now. We want to determine that there might be, like, for example, here in A. A has 7 possible zeros. Where am I getting that number from? If you are, hopefully you're trying to guess, but if you look at your degree is 7. Fundamental theorem of algebra states, if I have a polynomial function to the nth power, then there may be n roots. So if my degree is 7, I might have 7 real zeros. So our job will then be to find those 7 real zeros that there might be, and there might not be. So I may only have to find 3 or 5 or 1. Just, it's going to depend on if they're all real or not. And that will be another day. So now we need to determine how many positive or negative zeros there might be. So I know that there are 7 possible zeros. So I'm going to move this a little bit. I'm just going to move that down. Now, to determine the possible positive zeros, you are looking at the sign changes. So when I am actually, let me just get rid of that. When I am checking sign changes, what I mean by that is you really have to look at what are the signs in front of each of your terms. So to go from a negative to a positive, that is a sign change. To go from positive to a negative, that is a sign change. That is a sign change. So for the possible positives, I had 3 yeses. So there could be 3 positive solutions, but there could also be only 1 possible solution. The reason for that, we always have to take away 2 because if I am solving x squared equals 4, so I'm looking over here for your extra notes, and I square root that, I get plus or minus 2. So that's 2 solutions right there. Now what if I make that 4 negative? So now I have x squared equals negative 4, and I square root that. I need to remember that because that negative is inside, I will have 2 imaginary answers. It's still plus or minus. This becomes plus or minus 2i. 2 solutions, but they're not real. They are imaginary. So I need to think about that. That might actually happen. I might have an imaginary root. And if I'm given 1 imaginary root, then there are 2 imaginary roots. So please remember, you must take away 2. Now let's pretend that I had only gotten 1. Can I take 2 away from 1 and then I get negative 1? Is that actually going to be a logical answer to say, oh, there's going to be negative 1 amount of zeros? That makes no sense. You're either going to have a 0 or you're not going to have a 0. So you will not have a negative amount of zeros. That's like saying and being excited about having a negative amount of money. Okay, so you're not saying that your x could be negative 1. You're saying that there will be negative 1x intercepts. That just doesn't exist. So that's the possible positives. Now we're going to look at the possible negatives. In order to identify the negatives, you must put a negative x in everywhere you see x. So negative 4 times negative x to the 7th plus negative x cubed. And please make sure you use parentheses. Now, you're going to have to make sure you remember, if you have an odd exponent, the negative will stay negative. If you have an even exponent, it is going to become positive. So this would be negative 4 times negative x to the 7th plus negative x cubed minus x squared. So I did the exponent first. Now I'm just going to multiply through. Now it's a negative times a negative will equal a positive. This stays negative or becomes negative, negative, positive. So I'm going to check sign changes again. Positive to negative, yes. No. Yes. So I saw 2 sign changes here. So for the possible negatives, negatives. How many sign changes did we have? We had 2. And if I take 2 away, I get 0. So it'll either be 3 or 1 positives or 2 or 0 negatives. So let me just show you that one more time over here. My degree is 5. Since my degree is 5, there will be 5 possible zeros. So now I need to determine the sign changes. No, 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 no. So for positive, there are none. There will be no positive x intercepts here. So now let's determine the negatives. Negative x to the 5th plus negative x to the 4th plus negative x squared plus negative x plus 1. So this stays negative. Because this is even, it will become positive. Even becomes positive. Odd becomes negative. And that doesn't change. So now we're checking sign changes again. Yes. No. Yes. Yes. So there are 3 yeses. So the possible negatives are 3. And then when I take 2 away, 1. You'll see why we need to do this in the next video. It is actually very important that you guys get this down. It's going to save you a lot of time in guess and check. All right, now the last example here. Listing the rational zeros. So rational, we need to remember, are Our real numbers, they could be fractions, they could be whole numbers. We're trying to find all of our real zeros. We're not finding them. We're just going to list all the possibilities because I don't want to check numbers that are not going to work. So to do this, there's really a nice way to do this. We look at our first term and our last term, and we identify what numbers divide into those. So what numbers divide into 3, 1, and 3? What numbers divide into 1? Just 1. That makes this super nice. Your first value is your Q's. Your last value are your P's. So when you're finding the rational zeros, it is your P's over Q's, and they're always plus or minus because I don't know if they're going to be positive or negative yet. That's what I check for. So I look at my factors. P was 1. So to find my P over Q, P is 1. What is Q? Q is 1 and 3. So I have to put a 1 over 1 and a 1 over 3. You have to use each P for each Q. So you'll see in this next one, we're going to have a lot to write out. So now I just need to make sure I put plus or minus. So my possible rational zeros are plus or minus 1 and plus or minus 1/3. So that narrows it down. So instead of looking at an infinite number of zeros, I'm only looking at 4. Plus or minus 1 and plus or minus 1/3. Now you're really going to see this here. What divides into 4? 1, 2, and 4. And those are our Q's. What divides into 6? 1, 2, 3, and 6. So we got our work cut out for us. So I'm going to start this. Don't forget it's P over Q. And the P's are 1, 2, 3, and 6. So I'm going to start with 1. So I'm going to put 1 over all of my Q's. 1, 2, and 4. Now I'm going to go to 2, which is the next P. 2 over 1, 2 over 2, 2 over 4. Now I'm going to go to 3, which is the next P. 3 over 1, 3 over 2, 3 over 4. And then the last one is 6 over 1, 6 over 2, and 6 over 4. Whew, that's a lot of zeros. But I want to simplify. Some of you, as I was writing this down, you're probably thinking, why is she writing that again? We already have that. So let's simplify this. So plus or minus 1. So I'm going to start at the beginning and I'm going to work my way through to the end, and I'm not going to put any repeats. 1 over 1 is 1. 1 over 2 is 1/2. 1 over 4 is 1/4. 2 over 1 is 2. So I don't have any repeats yet. But now look what happens. Whoa, wrong one. Here when I get to the 2 over 2, well, that's 1. I already have that, so I'm not going to write that one again. 2 over 4 is 1/2. Not going to write it again. 3 over 1, so plus or minus 3. 3 over 2, don't have that yet. 3 over 4, don't have that one yet. 6 over 1, don't have that one yet. 6 over 2, what does 6 over 2 become? 3. Oh, I have that one, so I don't need to write it again. 6 over 4, what does that become? 3 over 2, which I have. So I am done. I have found all of my possible rational zeros. Tomorrow, we will actually be taking these rational zeros and finding which ones are actual solutions to some equations. But that's a lot to try. And that's why we narrow it down to positives and negatives also, like we did in the previous example. And then we use synthetic division. So that's what's going to be coming up in the next video. Please make sure that you get this practice done before you start throwing all this into the solving part of it. Get this classwork done. Come in with questions if you have any. Go back and rewatch this if you need to. And I will see you tomorrow.